My name is Chris Hirschi. I went to the University of Utah and earned both a bachelor's and master's degree there in mechanical engineering. Sarcos has been affiliated with the University of Utah ever since it began. It actually started as the Center of Engineering Design on the University of Utah campus in the engineering building, and right now is located next to the university in Research Park. When I was an undergraduate at the University of Utah, I worked in a research position for a professor I had, which was a great opportunity for me, helped me do actual real research as an undergraduate. And not only that, but the experience I got there and the recommendations from my professor there, I was told was very instrumental in getting a job at Sarcos. During my graduate work, my graduate supervisor was Dr. Miner in the mechanical engineering department, and he was able to get a faculty position for the summer at Johnson Space Center in Houston, and he was able to take one student along. So he brought me along, and we worked on a robotic tether system for astronauts to use when they are doing spacewalks. Right now I'm a mechanical engineer for Sarcos, who builds robots mostly. So I design the mechanical systems of these robots, mostly small mobile robots. Some of the other robots Sarcos has made that are known out there are entertainment robots that Sarcos did many years ago. It was before my time, but the dancing fountains at Bellagio Casino in Las Vegas were designed by Sarcos. There are many robots done for Disney. The Jurassic Park, Universal Studios theme park in California, those were designed and built by Sarcos. Big Arm is one of Sarcos' robots. It is what we call a master-slave system, meaning the master is what the person controls and the slave follows it. So the person that's driving Big Arm moves their arms inside the master and moves the master around, and the slave portion of the robot, which are the larger, stronger arms, follows all the same motions. You basically have a large, strong robot that has the same coordination of a person. Some of the applications for Big Arm, there's kind of a range of lifting things where it's too heavy for a person, but it's not heavy enough to warrant using like a forklift or a crane. And it's kind of in that little middle ground that Big Arm can really be useful, where you're moving heavy things, but they're not enormous things. There's certain manufacturing facilities that we've talked to that talk about how just moving plates of steel around, they're too big for a person to use and they're too dangerous for a couple people to try to move around. And the equipment they currently have are these bulky cranes that they take a long time for one or two people to operate to move these things into place, where Big Arm could just pick one up and move it. So we've been told that lifting up one of these cut pieces of steel that takes Big Arm less than a minute to do, we could just pick it up off a pile and place it, could take up to 8 hours for people on the manufacturing floor to wrangle around, because they have to deal with cranes and safety and staying out of the way. And with Big Arm, the person's out of the way of harm. There's no one around the steel. It's just the Big Arm moving it around. More recently, some of the fun projects Sarcos has done are an exoskeleton, which is kind of similar to the Big Arm. So the person's wearing the robot, and it moves and follows the person, but it amplifies his strength. And so it allows a person to lift much stronger weight or carry a much heavier pack, or many other things that basically amplifying the person's natural abilities, strength, but making use of the person's coordination. The engineering program at the University of Utah is very strong, and I benefited a lot from the classes I was able to take in robotics and electronics and controls. My name is Chris Hirschi, and I am part of you.